All right, let me get caught up, and for those just joining us to get caught up here. So I know you guys already have this down, but Leslie's starting at the starting line, so her start value is 0, her change is 2, because she's going 2 meters every second. So my challenge to you is, can you write me an equation for that? Y equals something x plus something. Can you remember where the 0 and the 2 are going to go in your equation? Which one's going to go in front of the x here? The 2, because the change is always attached to the x. And then the start value is at the end, it's not attached to the x. So y equals 2x plus 0. And do we really need that plus 0 on there? Could we just write y equals 2x? That would work. That would be just fine. All right, Kristen got a head start. Kristen, when we read it, it said she started 8 meters into the race. She got an 8-meter head start. And her change was 2/5. Can you write me an equation for Kristen, please? Y equals. Evie got a head start of 6 meters. And her change, or her speed, was 5 meters every 4 seconds. So see if you can write me an equation for Kristen and Evie, please. The equation's already, oh, you do. All right. What do you suppose we're going to do with these equations on this giant piece of graph paper that I just gave you? Yeah, we're going to graph them. We're going to graph them. So I'm going to go ahead and do Leslie first. So when I look at this equation, I look at my y-intercept. My y-intercept's at 0. This is my y-axis here. So I'll draw my first point at 0 on the y-axis, because that's our y-intercept. That's our start value. And my slope is 2. If I wanted to write that as a fraction, it would be 2/1. Remember, that's rise over run. So put your pencil down at that first point you drew, and then count up 2 and over 1 to create a new point. Up 2 and over 1. And then keep counting up 2 and over 1 until you run off the edge of the graph. And you've got a ruler there, so go ahead and connect up those points, and we'll get a line for Kristen, or sorry, Leslie. I mean, it's probably a good idea to label these. We're going to end up with 3 lines on the same thing here. So I'm going to write Leslie's name up at the top of this. Or you could just do an L. Yeah. L and K and E. All right, I've got Leslie graphed here. I'm going to move on and graph Kristen next. Let's look at our information here. We said Kristen's equation was 2/5x plus 8. So this plus 8 tells us where to start. So go ahead and draw your first point for Kristen. It should be on the y-axis here at 8. Draw that first point there. And then look at your slope. Remember, slope is rise over run. We're going to go up 2 and over 5. So from here, I'm going to go up 2 and over 5, draw new points. Up 2 and over 5, up 2 and over 5. We're going to keep going until we go off the edge of the graph. And we'll label this Kristen. And then once you get done with that, go ahead and graph EV. Same idea, look at where she's starting. That'll be where you start on the y-axis. So EV is going to start at 6 on the y-axis, and when we do our rise over run, we'll count up 5 and over 4. All right, so I'm going to pause for a second, make sure everybody's got all 3 lines drawn. Now we're going to do some analysis on this. So just by looking at these graphs, there's some important information that we can determine about this race. So this came up in our homework discussion at the beginning of class. Who was riding the fastest? Leslie, Evie, or Kristen? Who was riding the fastest? Say that again. Why do you think Leslie? She had the biggest number. Where at? So you're looking at the numbers for the change here. Interesting. So the biggest number. So you're saying 2 over 1 is bigger than 2 over 5 and 5 over 4? Is that true? As a decimal, this would be 2. Anybody know what 2 divided by 5 is? 0.4. Anybody know what 5 divided by 4 is? 1 point close, 1.25. So I'd say you're absolutely right. Yeah, Leslie definitely has the biggest number for the change. If we look at them all as decimals, so we can actually compare them, Leslie has the biggest number for change. So because this is the biggest, that means that Leslie is the fastest. How can we tell by looking at the graph? What if we didn't have those numbers down there and all we had was the graph? Would we still be able to tell from the graph that Leslie was the fastest? Yes, you said this earlier today, Jordan. How do we know that Leslie is going to be the fastest? Yeah, because look at this line is the steepest line. Do you agree? If I were going to be hiking up these three slopes, this would be the most challenging one for me because it's the steepest. So let's make a note of that too. This is the steepest, which means that Leslie is the fastest. That was going to be my next question. Yeah, who's slowest? Who's the slowest? Who has the least steep slope? Least steep slope. So Kristen, yeah. So Kristen's the slowest. We should be able to look at those numbers for our slopes and see that Kristen has the smallest number for slopes. And she does. That was the one that was 0.4. All right, so this is a 20-meter race. Who won? Who won the race? They all got to the finish line, but who got there first? Leslie got there first? How many seconds did it take Leslie to get to the finish line? 10 seconds? We should probably label these axes. What do you think? This is time in seconds. That's time in seconds. What would you call our y-axis? Meters. We measure distance with meters. I'm going to go distance in meters. So a moment ago, you told me that Leslie finished the race in 10 seconds. Do you see the point on the graph that shows that? 20 meters is where our finish line is. Leslie finishes in 10 seconds. Let's make a note of that. Finishes in 10 seconds. Leslie finishes in 10 seconds. When did Evie finish? We got to kind of eyeball this one. 12 seconds. It looks a little bit before 12 to me, right? 13 would be over here. No, she definitely finished before 13. We got to look at where she hit that 20-meter mark because that's our finish line. 11 and a little bit. What do you want to call it? 11.5, 11.6, 11.4? Somewhere between 11 and 12, agreed? She hits 21 meters up here at 12, but 20 meters is somewhere between 11 and 12. I'm going to say finishes 11.5. So she wasn't that far behind Leslie. She was only a second and a half later. She did get a head start, though, right? They must have known that Leslie was going to be the fastest at the beginning, and that's why they gave everybody a head start except for Leslie. All right, tell me when Kristen finished. So Kristen finished significantly later, after 30 seconds. All right, there's a couple other important things that I can see on this graph. Could I get you guys to look up the screen here real quick? What's special about this point right here? What happened in the race at that point right there? We see an intersection of two lines. Good. Great vocabulary usage there. But what physically happened in the race? If we were watching this race, something important happened in the race right here. All right, I'm hearing lots of good answers. I heard that's when somebody passed somebody. I heard two people were side by side, which is what would happen when you're passing someone. I heard a collision too. We're going to assume they were all in separate lanes, but you're right. If they were all in the same lane, it would have been a collision right there. So somebody passed somebody. Who passed who? Leslie passed Kristen, it looks like, right? Let's make ourselves a note here. Leslie passed Kristen how many seconds into the race did that happen? It happened 5 seconds into the race. How far were they from the starting line when that happened? That happened, they were 10 meters away from the start line. Ooh, I like that. Halfway through the race. Halfway to the finish line. Do you see any other places on the graph where somebody passed someone else? I see a couple more. Did Leslie ever pass Evie? Do you see that happening on your graph? Leslie passed Evie right here. How many seconds into the race did that happen? That happened 8 seconds into the race. And where were they on the track when that happened? They were 16 meters in. Okay, so we can see a lot of important stuff about the graph by looking at important points. You know what I forgot was, let's make a note of what this means right here. What's special about this point? What is this telling us about the race? What is this telling us about Kristen? That was her head start, right? She had an 8-meter head start. Likewise, Evie had a 6-meter head start, and Leslie did not get a head start. She started at the starting line. So you're going to do a couple more sheets like this. You're going to get a description like we had out of the book. And you're going to have to answer some questions. And you can answer your questions right on the graphs like I've done here, or you can answer them in your notebook. I'm going to have you guys work in your groups to complete one more problem like this. So you're going to be doing heat 2. If you flip your page over, which involves Elizabeth, Kay, and Hannah. Heat 3 is actually going to be part of your homework assignment. So problem 61 in your homework is going to be heat 3. By the way, heat 2, you can go ahead and write this down. This is on page 67. When you get into your groups, I'm going to ask you to grab a couple of books per table. And I'd like you, with your groups, to read through heat 2, which is on page 67. Create some graphs, and then you can answer the questions that are there. Figure out who won, who was fastest, who was slowest, what's up with the clown, all that stuff. There's a clown in heat 2, spoiler alert. Okay. In fact, let's add this down at the bottom of heat 2. I want you to write an equation for the clown too. Little extra credit there. All right, so when I say go, you're going to get your desks into groups, send somebody over to grab some books, and get started on heat 2 on page 67. When you finish that, call me over. Make sure everybody's got their graphs finished with the equations down at the bottom. Call me over, I'll check them over, and then you can start on the homework assignment. Before I forget, put this down at the bottom of our sheet, but I don't know if anybody saw this yet. I am announcing our chapter 1, chapter 2 test. It is on Friday, November the 18th. That's not this week. That's not next week. That's the week after that. All right. Go ahead and get started on that. I'll leave the homework assignment up here for you to work on once you're finished with heat 2. 1, 2, 3, go.